Welcome to EyeOpener, powered by Siemens. And now, your host, Gugan Sanger.
Hello, and welcome to EyeOpener, powered by Siemens. On today's episode, I'm delighted to be joined by Johnathan Bonner, Head of Solution Engineering at Siemens, where we are going to be discussing the topic around predictive maintenance and the need for hardware. So big welcome to Johnathan. If you could start off by introducing yourself, that would be great.
Thank you very much. Yes, so as you mentioned, I'm the Head of Solution Engineering. And really what that means for Sensei as predictive maintenance is before a project starts, we need to have a very good understanding of the setup, maintenance practices, infrastructure, the data, the assets that we're going to use for the project. And all of these need to be very well scoped out beforehand. So myself and the rest of my team, we're responsible for making sure that a project is reasonably successful before it even starts.
Perfect. Well, great. Really great to have you on today's episode. So I guess let's get straight into the topic around predictive maintenance and the need for data.
Yeah, so to make predictive maintenance work, we really are looking for three forms of data. The first is condition monitoring data, such as pressure, current, torque, vibration, temperature, speed, flow, and a full range of others. Along with that, we're looking for operational or contextual information. So if you have a different product running through the same packaging line at different parts of the week, we need that contextual information to give an indication of normal operating change. And the third form is maintenance data. Okay. So maintenance data is used not only to give an indication or logical indication of why something has changed after repair, but it also allows the application to build patterns and form information based around what maintenance was carried out.
Okay, perfect. So just on the first point that you mentioned around condition monitoring, are you able just to give just a bit more information about that technical term, because that's heavily used within the predictive maintenance industry? Yeah. It'll be great to get a bit more understanding about what that actually means.
Yeah. So predictive maintenance is actually an evolution from traditional condition monitoring. This is where, traditional condition monitoring is where a specialist would go around a facility on a route-based approach. They would collect data from machines such as vibration or run thermography scans. They then go and upload the data, have a look at it, analyze it, and then generate reporting based on the information shown from the condition monitoring survey. Predictive maintenance, again, as I said, uses that condition monitoring data, but it automates the process of collecting the data, of analyzing the data, and reporting. So you are effectively scaling the approach of a specialist to hundreds or thousands, tens of thousands of machines even.
Perfect. And then just moving into, so I know we're focused on this topic of the need for data, right? So if you could maybe go into that in a little bit more detail, because I understand that when it comes to individuals wanting to use predictive maintenance, they may already have existing infrastructure.
Yeah. And this is one of the key factors that we have to scope out before the project starts is what do you have existing already? So a typical infrastructure that we would see is on any industrial site, you'll have PLCs, inverters, drives that are all responsible for automating the process, automating your procedures and so on. There is data that is naturally within those. You will be able to get speed and pressure and current and so on from these devices. In some cases, you'll have edge processing devices on already installed. And utilizing the existing data within a site is extremely important because it's a massive win for no extra cost. If we can get to the existing data that's in a good format and a good structure for predictive maintenance, we can start to find value immediately and bring value to a project immediately without having to install additional hardware, additional time, additional costs, additional resources to do all of this. Okay,
perfect. And from your perspective, Johnathan, what would you say are different types of hardware that you've seen? Maybe going into that in a bit more detail, just around
So typically within an environment, what will already be there is PLCs, drives, inverters.
Okay.
You may have some additional sensing that's been installed. Quite often nowadays, OEMs are installing sensing in their machines already to capture relevant bits of information.
Okay.
Yeah.
So, Johnathan, from your perspective, what are the benefits of using existing infrastructure?
There are a number of benefits, because if you think about having to install something, you have to stop your process, stop your machines. You need to have the skilled resources to be able to install. There's loss in productions and a full range of other stoppages that you will incur if you have to install. So when you're using an existing infrastructure, theoretically, the amount of work to access the data that it holds is a lot less. You have a lot less stoppages and downtimes. You don't need as many specialists to do the installation. And there's generally a wealth of useful information already there. So if we look at some of our clients within automotive, they've been able to run entire successful projects without installing any new sensing. The information required for predictive maintenance was already there and has shown great success. If we look at industries like metal and mining, the amount of data that already exists in these environments is huge. And it's just about being able to leverage that for use in predictive maintenance. There are a full range of industries that have aged equipment, older infrastructures, but still have a wealth of useful information and data to use.
Yeah.
So really it's around cost saving, time to implementation, but also just being able to run full projects.
Yeah. I think that's an interesting point you made, because when it does come to existing infrastructure, people don't realize how much information and useful data they've got. So it's just having that, that specialist coming in, especially within predictive maintenance, to assist and say, well, hey, you've got this data. We could help you to look at it in further detail and then optimize and use additional hardware, right?
Yeah, absolutely. And we've got a very structured process on how we find out what is the right data. So first, we would want to understand the operation or the assets that we're monitoring. How are they operating? Is there operational complexity and interdependency between different assets in different areas? We then want to find out how does these assets fail, and what are the failure modes unique to your environment, how you're using these assets. And from there, we can assess the data that you already have. So at this point, there's a tie-in between data and known failure modes. How does this data relate to known failure? And at the end of the day, in some cases, there isn't enough data to have 100% coverage, but it's all right because you have 85% coverage or something like that. So you can still have a huge amount of cover from predictive maintenance with your existing data. And we run through this process of investigating that for you and then make the decision on whether or not additional hardware is required.
Okay. And typically, how long does that process take?
Oh, that's a how long is a piece of string question. Typically, that can be covered with 1 or 2 days on site.
Right, okay.
So an actual site assessment from the team. We'll go in, have a walk around, understand the processes, the assets, get a list of what data is available for these assets. And then to make the comparison between data and failure modes could take a few days. So really, you could be looking at a week turnaround for that.
A week turnaround, okay.
In other cases where we may not have representation in that area, so we are relying for the sites to give us the information over email, whatever it may be. That can take a little bit longer.
Okay.
Everyone's busy. Everyone's got a day job, so getting feedback from the site can be a little bit troublesome. But yeah, you're not looking at huge amounts of time, especially for the initial assessments.
Okay.
What we're looking for before a project starts is not to have everything 100% nailed down. We're looking at do you have the right information that would be useful, and then once the project starts, we can do proper investigations on exactly what kind of coverage you can get.
Okay. Perfect. No, that's good to understand and know. So I guess I know we touched into this, topic around benefits of existing infrastructure. And I guess with regards to anything, there's always going to be the cons, right? So it'll be good to understand what are the problems that could potentially occur with existing infrastructures.
So if we look at the levels of existing infrastructure, you've got the hardware, PLCs, drives, inverters, as I've mentioned. You, in some cases, a factory will have a factory historian, an SQL database. In other cases, they may be using a SCADA system. And if you are having different layers with all good information inside of them, you now need to get them to talk to each other or have a centralized way of getting that data through to the cloud. So when you're looking at all of these different layers, they have different communication protocols, different ways of communicating, different ways of sending data outwards. So you always need to assess, how are we going to get the data? What communication protocol is this system using? Do we have something in common that could, a data acquisition device, for example, that can pull the data out to centralize it? So there is troubles with those type of communications. The second being, not everything is going to be programmed for predictive maintenance. So yes, a client may have a PLC used for automation, but that doesn't mean that it's naturally acquiring the right type of data. So we need to make sure that it is acquiring the right type of data. If not, there is work to be done around reprogramming this.
Okay.
Typically, clients don't want to let you anywhere near to the automation system, because as soon as you start messing around with it, it could fail and you could then have lasting production issues from there. Also, data quality may be an issue. When actually assessing what the time series data looks like, you may have things that are stored at super high frequency rates and other things that are stored at very low frequency. Typically, what we're looking for is a sample samples that are happening every second.
Okay.
Anything higher than that is extremely noisy. So with an existing infrastructure where you have super high sampling rates of data, you need to downsample, you need to aggregate, you need to process the data. And this all takes either rework on the existing infrastructure or an additional device to do.
Okay, no, that makes sense. And that takes me to the second part, really, which is more focused around the need to install additional hardware. So I guess that touches into what you mentioned. There could be issues with the data quality. What they have currently at the moment is not collecting data. And I guess that's where, we would then come in to install additional hardware to support.
Yeah.
Okay.
So again, we would follow the same process of understand the asset, understand its operational complexity, understand how it fails, and understand what is available. From there, we can then assess the gaps. So if you're looking to monitor bearings, for example, and there are billions upon billions upon billions of bearings out there, the most effective way to do that, or one of the most effective ways, is through vibration. But you need to assess, is vibration needed? Yes. Understand the operational complexity to say what type of vibration is needed, because not all vibration is the same.
Okay.
In some cases, you can have very simple RMS vibration readings. In other cases, you can do full FFT analysis, look at the spectrums, the waveforms, and be very specific around the failure mode.
Okay.
So when assessing, you need to see what is the type of additional hardware that's required. So what is your output? What is the data that's going to come from it? And is there a need for it? Yes. Okay. Then you can start to assess the types of sensing, the different suppliers that there are, the outputs of it. What does it take for this system to function? Because really you have 4 different types of sensing in the sense of its structure. So one type of sensing is your sensor. You'll have a data acquisition. There will be a cloud replication service. Typically, this will be the client's cloud.
Okay.
And then we would connect that through to the Senseye cloud. The next one is you have your sensor, a gateway, which pushes directly through to the Senseye cloud. The third form is your sensor, data acquisition, gateway, cloud. And then the fourth is dumb sensing, which is typically a 4 to 20 milliamp output, which will go into an existing infrastructure route.
Okay.
So you need to think of what is going to be best suited for your environment. Then again, the suppliers, find out the costs. Is the cost to benefit ratio there? Does that make sense? And then look at installing that. So there is quite a process to defining the right solution for the right application for the right client. So when you're looking at a project, you're scoping out a project, there has to be, as I've mentioned, the cost versus benefit ratio. That has to make sense. And when you are installing additional hardware, you can really make sure that you have the right data, the right quality, the right sampling, the right measures. Everything falls in place because you are deciding on what it is you're installing. So for example, we had a client that makes cardboard boxes, and we, for whatever reason, weren't allowed to go into their existing infrastructure. We weren't allowed to get any of their existing data. So we had to help them scope out the entire process, the entire stack, the full stack solution from sensor all the way through to Sensei. This meant that we had to find the right type of sensors for the right type of machines. Some were basic bearings just on rollers. Others were complicated motor gearbox combinations, couplings. So different sensing requirements for different assets. We also had to help assess the right automation layer because we used PLCs to take in the raw vibration signals, process them correctly, and push it through to the cloud. So in this case, we had a direct connection to an OT layer through to the cloud, but it was dedicated for vibration. All of this is extremely costly. So the entire project with installation costs, the cost for the hardware, the cabling, and all of the cableways that had to be created brand new, we're looking at hundreds of thousands of euros. But the benefit for them was they had full coverage of an entire cardboard corrugator line. Okay. They could understand exactly, long time before anything happened, what was going to fail, and they could plan it in. And I believed they achieved an ROI with that in 4 months.
Oh, wow.
So in that case, by being able to reduce their unplanned events, giving them planning time, an early indication of asset degradation, they were able to change their maintenance practices and get value almost immediately. When you are looking at the payback for hardware in a project, typically customers would look for a payback within 5 years. So there's a separation between your initial hardware investment and then, let's say, the project investment. And payback should be, as I said, 5 years, in this case, 4 months. It absolutely made sense for them.
Yeah.
And we were able to customize and tailor everything as it should be. We were getting fantastic data, and we've been able to scale this out to multiple facilities.
To find out more, search Sensei Predictive Maintenance.